In this problem, we're given the test statistic of z equals 2.52, and we are told that the claim is that p is greater than 0.16, so that means that this is a right-tail test. We're going to use the critical value method for determining whether to reject or fail to reject the null hypothesis. So I start off with the significance level of 0.10. And that means that my rejection region or critical region is going to be the upper 10% of my normal distribution because we have a right-tail test. So if there's 10% in the right-hand tail, that means that there is 90% on the left. And so I'm going to use the inverse norm function in the calculator. We put the percentage on the left, and then the mean and standard deviation are 0 and 1. And when I calculate that, this gives me my critical value, and that is 1.28. So that's what we put there. And then the question is, should we reject the null hypothesis or should we fail to reject the null hypothesis? So now I'm going to look at my test statistic 2.52, and that would fall, let's see, we've got our critical value is 1.28. Then the test statistic is going to be about here at 2.52. That is in the rejection region, so the null hypothesis should be rejected since the test statistic is in the critical region, and so A is the correct answer there. Now let's take a look at another example. Here it says the test statistic of negative 1.38 is obtained when testing the claim that p is not equal to 0.345. So we're doing a two-tail test here. Again, we have a 0.10 significance level, but in this case, because it is a two-tail test, we have to split the 10% between the two tails. So we're going to have 5% in the left tail. Oops. I just write 5% instead of converting to decimal, and 5% in the right-hand tail. So to find my critical value, or critical values because we have two of them now, again I'm going to use the inverse norm function. And to find this first critical value here on the left, I'm just going to put in 0.05. That's the area on the left. And when we put that into the calculator, I get negative 1.645. So this is actually going to be a little bit further to the side here. So we've got both our positive and negative critical values. We just calculated negative 1.645 for the left-hand side, and then the right-hand side, we just have to make that a positive. So now I've got my two critical values. And here they have it rounded to 1.65. It just depends on how many decimal places they want to have that for. So we've got our critical values, and now we are going to look at where is the test statistic. And that's at negative 1.38, which would be maybe about here. So that is not in the critical region, So we are going to fail to reject the null hypothesis, or do not reject the null hypothesis. So let's see, we don't want A. B might be right. C is wrong because it says it should be rejected. So we're choosing between B and D. And since the test statistic is not in the critical region, that's why we are not rejecting the null hypothesis. That's why B would be the correct answer. So that's how you do those two problems.